Welcome. The real question is if I run around a lot, if the guy in the back's going to get really angry with me. No, you're good. All right. Hello. There are clown cars outside. As the clown sound comes, Laerte shows up. You clearly have seen one of my presentations before. That's when he starts tweeting out, he's giving away money.
Do you want me to send that out now?
Sure, yeah. It's Canadian money. Is there a number of honks for when I'm supposed to start, or?
172.
I can't count that high. I went to public schools. Give it a couple of seconds till this thing clicks over to 11:30, then I'll start right on time. We're waiting on you, Mike. You're like that last person on the charter flight. All right, I'm going to go ahead and get started. I'll grab the door. Or you can grab it. Welcome, everybody. This is Stages of Database Development. I am your host, Jeremiah Peschka. A little bit about me. I'm a Microsoft SQL Server MVP. It's an award Microsoft gives out for talking a lot about SQL Server. So if you have questions about SQL Server, about anything we're talking about, ask them. I like talking and answering questions. That's why I'm up here. I am a database consultant. I started this company with Brent, Kendra Little, and about 2 years ago now. I invented feedback. Oh, I bet that's a cell phone. Yep. I know a lot about CDMA. I take tests incredibly well. I have a bunch of certifications in SQL Server. And one of my hobbies is I maintain a database driver for a distributed non-relational key-value database called React. I do that in .NET. It's a lot of fun. So our goals here today is we're going to talk about database development. We're going to understand how these tools can help augment and improve your processes. Databases are typically left out when you hear developers talk about development lifecycle and agile processes. They're sort of like, and we're going to do agile over here, and there's a database over there. Let us not speak of it. It is over there. So we're going to talk about a clear path to improve your processes, give you actually stages you can move through to get to a better, happier place of database development and making things awesome. So we're going to talk about development. But first, we're going to have a poll. How many of you guys are developers? All right, give me hands up. How many of you are writing unit tests? Everyone who put your hand down should be ashamed. How many of you are using continuous integration? A few. It's actually more than I thought. Awesome. How many of you guys are using continuous deployments? A few of you.
Could you define deploy?
Deploy pain. Okay, so that's good. I want to know about that. How many of you guys are now database admins and developers? Some of the same people. How many of you are writing database unit tests? You are overachievers. And how many of you guys are using continuous database level integration? You're doing integrations against your database, just like you would run integrations against your .NET code or your Java or your PHP, your Algol, COBOL, Fortran, whatever you got. All right, so this next question, then no one's going to answer this well. Every time you check code in, you run tests. You run integrations. Woohoo! Too expensive. All right. And how many of you guys are doing sort of continuous deployments when you can push code constantly throughout the day? All right, cool. I actually got interested in this because I tended to talk a couple of years ago when Etsy revealed their deployinator tool that they used to deploy 45 to 65 times a day. They have a separate deployinator that they use just for database development. They have one they use for the web code. They literally, there's a button that just says deployinate, and they click it, and it deploys code to the production site live. And their processes are such that they can do this. This is normally what we think of as a software development lifecycle, right? We have these circles, and we keep going around and around and around, and it never ends. This does not help you assess your process. Nowhere in here does this say, are you testing your code, and did you back up your database today? Those are key important questions. Right, we go through, and there's a QA, but that's a bunch of people that we don't like because they find bugs. So we'll sort of address this as we go through. But it doesn't help us find our process and make sure our process is fine-tuned and running smoothly so we know our code is always safe and we can move it to production whenever we need to. We'll talk about, well, development, really, not really maturity, with a little history lesson first. In 1950, a gentleman named Erik Erikson wrote Childhood and Society. Right? It's a fantastic book that I've only read parts of because it's psychology and it hurts my head. But in this book, he outlined 8 distinct stages of development that we all go through from birth to death. And this is where identity crises come from. And all these stages, though, have a core of virtue and conflict. And these are things like hope and will and autonomy. And you work through this, and theoretically, as you go through this, you derive these virtues from all the things that you go through and become a more whole and complete person. And shockingly enough, for modern pop psychology, it actually lines up pretty well with how humans work. So what we're going to do is steal and or build on his hard work. Erik Erikson had 8 stages, and it looks roughly like this, where you go from trust and mistrust, and you go through this whole thing, and there's long definitions of each one, and I put it in black and white because it's kind of dull. The descriptions are very lengthy, and there are virtues and everything, but I thought I would spice this up a bit and make this a bit easier to understand rather than having to do things like equate things like initiative versus guilt with databases. Like what's my guilt versus initiative? I took a backup. Oh, I'm sad. No, I didn't do it today. Should have written a script. So I came up with my own ideas, which are just actual actionable things that you can do. So you can move from a state of taking backups to going to unit testing, having alerts, having database migrations. Migrations are awesome. They make life so much better. You can move code forward and backwards safely and go, yes, no, this hurts, it doesn't, yay. To even getting up to continuous integration, where you can just click buttons and things happen automatically for you. This is so you can look at cat pictures at work. At the end of the day, there's a cat picture up at the top of this pyramid. So with backups, right, we want to ask ourselves, how can I trust that backups are working? Yes, which of course, though, leads to bigger questions, right? Because what do we do to secure this trust? What do we do to make sure that our data is secure, that we know our data is good and is consistent, and we know that people cannot steal our data? I was working with a state agency in Ohio at the time that an intern had several terabytes of tapes stolen from the backseat of his car that contained Social Security numbers, and the state of Ohio had to purchase identity theft protection for every employee in the state of Ohio because someone left unencrypted tapes in the back of their car. So we want to make sure we have trust, that people can trust what we're doing is a good thing, and that even if someone does steal the tapes out of the intern's car, that they were encrypted. So some of the things we want to do is we want to make sure we can schedule this security. We want to have scheduled backups, scheduled restores, scheduled DBCC. We want to make sure that we have encrypted these backups and that we try to mess with these from unsecure sources and we can't get to it. We want to think like evil people who are going to steal our data, right? We want to do awful, awful things after we make it safe. Now, to get all of this in place, you could write scripts, right? You could spend a lot of time typing, hunched over your keyboard late at night, lit by the glow of your monitor, sad because you'd rather be at home with your family, but you had to write scripts. Or you could use a wizard. And really, this is fantastic. This is actually, I was messing around with it. You can just click through, and the SQL Backup Pro will actually click through, and you can encrypt backups with clicking. You can compress. You can schedule restores all through one wizard across the entire environment, which is much easier than writing scripts. Yes, you could write PowerShell to do this. Yes, you could write T-SQL to do this. How many people would rather focus on mission-critical things that they love? And yes, this is mission-critical, but odds are writing scripts to do all of this stuff is probably not something you love. If you do love it, you probably work for Redgate. Or you just really like it. One of the nice things, though, is with your scripts, you're still writing this by hand. Here, you can actually add in a console that lets you view the entire environment as a whole. You can see, OK, where are my backups? Where are they going? Do I have centralized backup and restore jobs? Normally, we have to write this on management servers and do a lot of extra work yourself. You can get to this place by hand if you're cheap. Software is usually a rounding error compared to the human cost of building tools. One of the things I talk to folks about when we go and we work with clients, say, well, they're like, well, we're thinking about building this. So how many man hours do you think it's going to take? How many person hours do you think it's going to take to build this? Oh, about 100 to 200. Okay, what's the aggregated cost of an employee? Oh, it's X amount of dollars. And you say, so you think spending $30,000 to have someone write this plus the maintenance on every year is cheaper than spending like $500? I don't know about you, but I'd rather buy something and just complain to the people at Redgate when it breaks. They're like, do not invite Jeremiah back. So backups, you can schedule it. And we want to get all this stuff scheduled so we never, ever have to think about backups again unless developers say, can we restore the backup somewhere? And say, yes, clicky, clicky, it's done. So this is our first stage. Backups. It's very easy to do once you automate all of these tools. Now, unit testing, right? Once you get your backups in place, you can safely say, I have backup jobs that work. They email me when they explode. They email me when restores don't happen. They email me if a DBCC fails and I find out I have corrupted data. Right? I can trust my data. Now we need to work on trusting our code. Because nobody trusts code because I don't know what the Yahoo in the next cube is doing. He's probably looking at cat pictures. Even though he has work to do. He's still here. He's not up here where the cat pictures are. He's trying to jump ahead. So testing code gives us trust in our environment. Again, a lot of this is about trust, that people can actually say, OK, this is good. I know everything that I have is good and safe, and there's not a fire lurking somewhere secretly inside this database. Nothing gets slower. One of the biggest things that we always want to do when we push code out is we make sure that we're not introducing a breaking change. We don't have a view that does select star and that it gets recompiled and things that call that and don't expect a new column suddenly break. Because when you recompile a view, all the new columns show up, but not before then. Awful things can happen sneakily inside your database if you aren't actually watching and testing everything. Just like developers, everyone who raised their hand when they said, yes, I unit test my code. You know why you do this. You don't want sneaky changes to come in and suddenly reset everybody's credit card number to 3. It's not going to help you with your recurring billing processes. We don't want to have updates in the database that do this as well. We want to make sure everything works. And really, a unit test, for those of you who don't do this, a unit testing, we want to test the smallest part of functionality so we can verify that one thing is working well. So we want to know that updating a user's first name just updates that user's first name, not every user's first name. We want to know that all these tiny pieces of functionality work. This will be at the stored procedure level, the view level. You want to make sure that the view actually returns the correct data, whatever you're changing. You want to know that it works. You could do this by writing your own framework. And I did this one night. because I got very bored several years ago, and it's terrible and painful, and you have dynamic SQL that writes dynamic SQL that writes dynamic SQL, and it just, your head hurts, and you're like, how many single quotes do I have to put in here to make this work right? And the answer is no. LOL, no. Do not, down this road lies madness. Please do not do this. So knowing that it would be insane to sit down and put in Apocalypse Now and just start writing our own unit testing framework, that's how I do it. I put in the director's cut of Apocalypse Now, and I figure if I can finish something in 3.5 hours, it probably is a sane idea. If it takes longer than that, I should just buy it. So we want to look at existing tools, because somebody else has to have had this problem before and solved it well. And it turns out somebody did. And a couple of guys who are speaking later on today wrote a unit testing tool framework called T-SQL-T, and it is free and open source. You can just install this, and you can actually start running all of your unit tests. You can define how the data is supposed to behave, what things should look like as you work through it. And you can even, using Redgate's tools, write and run these tests within Management Studio. So you get nice little checkboxes or red awful things that show up next to your failing unit tests. So you know that everything is working or is broken and on fire. And of course, Management Studio is where you do most of your work, right? Who actually develops using the Visual Studio database tools? Yeah, like 2 of you. Someone who's sort of ashamed. They're sort of painful. It doesn't feel quite right. It's almost there, but the parts where it's not almost there is like a tiger trying to eat your hand as you're writing code. And it doesn't work that well. Management Studio is where most database professionals spend their time. It's even where developers spend their time when they're working with the database. So this is baked right into Management Studio. And I could tell you more about this, but I won't, because the people who wrote T-SQL-T are here this afternoon talking at 2:40 p.m. And if you really want to know, I could summarize it badly, or they could tell you everything you need to know in glorious, glorious detail about unit testing with T-SQL-T. Sort of why I'm just glossing over this vast subject. There are also fine people in red shirts wandering about. Not that guy with no hair, but that guy with hair. That kind of red shirt, who are walking around who worked on these tools, and they can tell you about, okay, you heard about T-SQL-T, here's how this interfaces with Management Studio, so you can run these tests on a regular basis. But the idea is that we put these tests in place and we start testing every piece of functionality at a certain level of abstraction, so we know that all of our tools work. One of the things I recommend is that you have a database that's a known testing state, and you restore this and you start working with your tests on it. So that way you know that I'm updating Martha's name to Joan or whatever I'm doing, and I know that it's user 1234. And you can start even adding performance tests in that I know when I do a select with 10 users, it takes this much time. When I do 100 users, it takes this much. When I have 1,000 users, it takes this much time. So you can even start getting validations in about how long things take. So that way when you change a query, you know that it's not getting slower. Hopefully it's getting faster. But worst case scenario, we don't want things to get slower because of changes we introduce. Makes sense, right? You guys want to make things slower randomly? Everyone raise your hand. You're a consultant, you don't count. Wait for delay 4,000. I'm just going to comment out this code. Look at how much money I just made. That's what we all think consultants do, right? Even as a consultant, that's what I do. So we talked about backups. We know our database is not going to catch fire at 2 a.m. when we're sleeping, just replication. It's a different beast. We talked about unit testing. We know we can now introduce tests on top of, is the database not on fire? Is it encrypted? Is it safe? We now know that the code that the guy in the other cube is writing is good. I know that my code is good. And if something breaks, I'll get an error message that says, aha, Brent broke the build in the database. And I can blame him and revoke his permissions to look at cat pictures. Yes. So, at this point, I cover this. We have tested code. We have working backups. We have restores that work. We have consistent data. It's encrypted. Nobody can steal our credit card numbers. This is all good. And our next big question is, am I healthy? Right? What is my state in production? I don't know how you guys measure health, but typically people want to look at CPU, I/O, memory, network. These are the 4 places you can have terrible pain. Anything else falls into one of these 4. It's just a fancy word for CPU, I/O, memory, or network. Now, you can get here, and again, you can write homegrown scripts to do this. I know lots and lots of people who do this. I've written this. I've written my own graphing. I put it into Excel, and it hurts because I have to keep maintaining it and changing it every time I change my queries, and then I have to figure out why it wasn't collecting data on Thursday, and it takes time. Or you can buy a tool. Right? This is, again, budgetary rounding error. It's a rounding error in most of our raises to buy these kinds of tools. I didn't say how big of a rounding error. It's certainly a rounding error, and for whoever signs the checks, like, what? How many zeros? 1. Awesome. So we can do this, or you can buy it. And it's going to look something like this. And you're going to actually be able to go in and look at these beautiful, beautiful graphs that you would normally have to generate yourself. You can say, oh, well, what's going on in this machine? What did you do at 7 a.m.? And it turns out that's when, we reset the web servers. OK. But you can tell things in there. The nice part is you can actually go in and add notes to the graph at any moment in time. So you can see what's going on, see notes, and say, OK, well, we rebooted the web servers here. So this reduction in CPU is not due to my genius indexing. It's, in fact, due to turning off all of the web servers. Or it could be right here that I added an index, not here. Index, reboot, index, reboot. So you can add all of it in. And this is a really, really good start. But we need to still see a lot of these. These are physical counters. But I also want to know about abnormal running events, right? What's going wrong? What's going weird? This does not show me when I have a long-running query. I do not know if someone actually started a terrible, terrible report at 3:15 in the morning and it actually just finished at 7:30. I don't know if that's what happened or if this is just normal behavior. So I need something that actually gives me more insight. And you can do that. You can have alerts, these built-in, beautiful alerts. We talked a little bit about some of this morning. This is still SQL Monitor. This is all in SQL Monitor. Thank you for reminding me to say what we were looking at. I did not pay this man anything yet. Come up afterwards to redeem your voucher. So these alerts are really cool because now I can see when I'm having disk problems, when I'm having I/O issues, when people are running queries for a long time, when I have a deadlock because, forcing row lock hints is awesome, right? I can find all sorts of really cool things. And you can go into these and treat them like issues and actually add comments into them and see what's going on at a given point in time. So if I click on one of these alerts and actually start digging in, I can see what's going on at the time the alert's triggered. So I say, aha, here's when my alert is triggered. What's actually happening here? And it turns out there's a lot of squigglies. That's disk access time. So I can start seeing what's going on with the disks at a given time. I can look at memory, CPU, and figure out, OK, well, these are what's going on. I've captured queries that are actually running at this point in time as well. So I can dig in and put all my comments in, look at exactly what I've captured. And then I can grab all this data, push it out somewhere, or just show it to the other DBAs and say, OK, what do you guys make of this? So it gives me a really easy way to dig in to a lot of these issues and figure out exactly what the problem is. If you write all these scripts to collect it yourself, and you guys are like, yeah, I could write scripts to collect this kind of stuff myself, because you're all smart people, you still have to go and then query that from the database and put it into Excel and then email it around the team and hope that nobody changes anything in that Excel spreadsheet and only saves it to their computer. And it's just sort of painful. And this is all pretty cool. And you heard this morning, too, about version 3.2, which lets you add custom metrics, which are written by fine folks like you and me. You can even see what the custom metric does. And the key thing to remember is look at what it does and verify it, because the one that shows you DBCC log info for virtual log files will crash certain versions of SQL Server 2005. Just FYI. It's a known bug that's never been fixed. No, I did not write that one. I did not write DBCC. I do not have a ponytail. No, I didn't write the alert either. And custom metrics, having custom metrics come in means you can actually have custom alerts. So you can start doing things like, what is a ratio of compiles to recompiles? What's a ratio of batch requests per second to compiles? So you can start building your own custom alerts that are specific to what you understand about your application in SQL Server, or even have your app start generating its own custom alerts and tables, and you can pull that out and get awesome custom alerts. Basically, anything that you can script can be monitored. So if you get new orders that go below a threshold per minute, You can alert on that. And that's kind of cool. You guys are very quiet. Clearly talking fast. So we've got alerts, we've got unit tests, we've got backups, right? We know what's going on now. We know our code is not catching fire. We know the database has not caught fire. And if it did catch fire, we would be well aware of it because we're looking at the fire. So we want to know about migrations. How many people have heard the phrase, "it worked on my machine"? How many people have said the phrase, "it worked on my..." Hand up, Brent. Yeah. Moving code between environments really does suck. Unless you have a very, very refined process on how to get code from your machine to the communal dev server to QA to test into production, this is a really, really painful process. And we need help to make this easily. And what a lot of people do is they develop on their local machine, which is why developers clearly need a SAN attached to their local server, their local workstation. Just need terabytes of storage locally. And we sync to a shared server every once in a while, so that way I can introduce breaking changes in the database, make sure it's all going to work, push it up to the shared server. We sync to QA, we sync to testing, some sort of training environment. We make sure everything is going to behave well. We hope nothing sneaky changes. We hope nobody wipes out production changes, and we move everything into production. And we hope this works, but this is really hard. This is not an easy process. This is why we're here to learn. I hope you're here to learn how to make this easy. If not, I'm really only giving him money, not everyone. And this is actually where a lot of things from developers come to the rescue, because developers have been trying to fight this problem for a long time. Database migrations are change scripts that you write in code. This is initially made very, very popular in the Ruby on Rails framework. Active record migrations really just describe how objects change in code. And then the tools figure out, OK, here's the roll forward script that I need to run. Here's the roll back script that I need to run. And the tools would generate roll forward and roll back scripts for you. So as long as your development team is very diligent about these changes and not looking at cat pictures, then it becomes easy to make these changes and roll them forward. Backups are really key in this process because you can say, well, I can roll things forward on the fly, right? SQL Server 2012 lets me add non-nullable columns on the fly, and it updates it sort of in the background for me, and modifications aren't blocking. Well, it's true, but when you start having breaking data changes, when you do something that's considered destructive of your data, you really want to make sure that you've got a backup in place. And migrations don't fully cover that. And there are easier tools to do this. You can use SQL Compare to grab code changes. And SQL Compare even comes with command line and API-driven tools. You can actually enlist your developers and say, well, I like what you're doing. I like your ideas. But let's actually programmatically look at these changes and address them in specific ways and make sure you kick off backups. And a couple of my clients are actually doing this, where they actually have API, they have build tools, and they launch a batch file, and they type in a build number, and it goes and it runs SQL Compare and actually restores a copy of the database. And it compares that restored schema to the production schema. It generates change scripts if it needs to, and then it moves forward, takes backups right before it rolls the changes out. It's actually really cool to watch them do this, and they do deploys in the middle of the day. I'm still not a huge fan of double-clicking on a batch file on a production server's desktop. RDPing into a prod machine to deploy code seems a little fishy, but hey, it works really, really well, so I'm not going to complain at them too much. You can also use SQL Data Compare, which many people have to update metadata, like lookup tables. It sucks, doesn't it? You're like, I got my copy here, and I got my copy here, and I check for the rows, and if the rows don't exist, yeah, this just does that. I don't recommend doing this against your 14 billion row fact table, because Data Compare is going to look at all the rows and see what's different and use all the RAM and then crash. It's not Regate's fault. You just don't have that much RAM. And you can use SQL Packager to make packageable deployments. So this is actually going to push executables, and you can push the executable to a server. Or who works for an ISV? All right, then none of you care. The people watching at home would be happy to know that if they worked for an independent software vendor, they could use this and package up database changes and make it part of their setup scripts. This is all really nice because it means you can do repeatable deployments. And when something is repeatable, if I run through a process 5 or 6 times and it doesn't explode, I have a pretty good sample size that says, odds are in production, this will not explode. Ultimately, I just want a pretty good chance of not catching fire. But tools are no substitute for human experience. These database tools cannot divine your intent and what you mean to do. When you rename a column, they don't see that you've renamed a column. They see that you dropped the old column and added the new column. This is really fun when you unexpectedly nuke everyone's credit card number. Oops. So I use automated scripts to write less code. There are very few changes that I can't do automatically. Changing column names I can't do automatically. But I usually use automated scripting to write less code, verify intent, look at the changes, and then make sure that what's going forward is safe. If you aren't doing things that are breaking changes, if you're always doing commutative changes, you're always just tacking things on rather than removing things, you can pretty safely just keep adding. It's convergence. We're converging on a consistent database, right? It all works. We come to the green step, the happy place, continuous integration. What is continuous integration, right? And I've been waving at the top of this pyramid now for a while. And continuous integration is a constant quality control process. See that first slide, there's that big loop and QA sort of at the bottom. We keep eventually looping around to QA, and it's like a waterfall software development model where we plan, and then we do a thing, and then we do a thing, and we go back to planning again. This is a 2-year cycle, and it's sort of like putting something on the moon, and we really don't need to be, if you don't work for NASA, you really don't need this giant paranoid waterfall model. We can be a little bit more agile. We can be a little bit more flexible, and we want to have constant quality control going on. Continuous integration goes and runs your tests whenever code is committed. So that way you know when somebody breaks the build. This is really funny when you first implement this because you could actually have it send out an email to everybody on a dev team. They even put the name of the person who committed source control in, or who did the last commit, and you can see, oh, Bob broke the build. And a couple of my friends, I've got a friend over at Microsoft who works on the IntelliSense team for Visual Studio, and they actually have like a platypus of shame that they pass around, and whoever last broke the build gets this ugly stuffed animal on their desk until somebody else breaks the build, which is, of course, very sad if people are paranoid about breaking the build. But you can build and verify a new environment in this process. You can actually, again, take your last known state, right, your good state, you have your good state database, you can restore it and then actually verify all of your behaviors against a known copy of the data and see what it looks like. You can test migrations to move your code forward. So not only do you know that your code isn't going to break, you know you can actually roll this code forward and no errors are going to occur. You're not going to try to use indexes that don't exist. You can test everything that's going to happen and be very, very paranoid about how you're going to move from today to tomorrow. You can just introduce a ton of paranoia into your process and practice things, not just a few times, but you can constantly be practicing through automated tools. The more automated you can make things, the more cat pictures you can look at, the more you can do fun things in your job. If you like tuning T-SQL, the more T-SQL you can tune, whatever you want to do. And this gives you a constant insight into your code stability and quality. You know what's going on. And I really like to know what's going on. Monitoring is like this sick fascination of mine. The more I can monitor, the more monitoring I want. This vicious cycle will never end, and I'm okay with that. Hi, I'm Jeremiah, and I love monitoring. It's just monitoring, though. It's the only thing, which is why I'm monitoring you. And if you think all this sounds hard, you're right. This is really hard, but we can do this. We've already gone over a lot of automation tools. The restore tools can restore things. You can use the unit testing tools. There's all kinds of automation you can build in here. You can build migration scripts automatically. You can even do database version control because, after all, you're all versioning your database code, right? Who's versioning their database? It's okay. Raise your hand. Pride. This is really, really important. This usually gets left out. And what's interesting is developers it's almost religion about how they version the database. They understand that it has to be done, but then there's various faiths about what tools you use to version the application code. And even operations staff have this religion about scripting every change they make to the Apache server or to Active Directory. Everything gets scripted and committed to version control. A lot of database people don't do it because we haven't just had this focus on making everything good and happy because we've got backups. And I'm just going to restore the master database because that's really easy, right? Yeah. And there is version control for SQL Server. Redgate's got SQL Source Control and SQL Connect, which will actually hook SQL Server into your version control. So that way, SQL agent jobs can get versioned because everyone always versions they always source control the code you're typing straight into that T-SQL task, right? And you always version those SSIS packages that you're running, right? Yeah. Everyone's like, sure I do. Note to self, version SSIS. But all of your changes should be controlled. You should know that when you make a change, you should be able to track it exactly down to who made a change, why that change was made, what is this associated with, why did I change max stop from 8 to 2, why did I bump cost threshold to 3,000, why am I doing all these things? You should know and track it because you want to be able to recreate this environment anywhere. Because, of course, servers and SANs never crash catastrophically, right?
The SAN never does.
Never. The SAN would never crash catastrophically. Yeah, but yeah, so awful things never happen in server rooms. We want to be able to recreate these environments that way if a customer wants a copy of our code on site, we want to be able to recreate this immediately for them. And with versioning, you can immediately create scripts. You can immediately deploy a version of your most current database, diff it against what's theoretically correct and in production, but may not actually be correct and in production. So you know where everything is, what everything looks like, and what it should be doing. Again, this is just paranoia, but paranoia pays off in the end, and you have a lot of stability as a result of this. You can recreate everything, and it's great and wonderful and fantastic. And you can even link everything to the application version, so you can actually say, well, we're going to deploy version 1.1.3 and push it out. That's a database with networking for work groups, by the way. And if you didn't get that, you're clearly not as weird as me. Windows 3.1 backers. Yeah. Oracle, what? And there's a lot of good resources about this, too. There's a Redgate guide to SQL Server team development. You can pick up a book downstairs. You can download a PDF online. From what I understand, it is a good book. I don't work with teams of people. I do not play well with others, so I have not read the book. Several of my friends wrote it and have reviewed it and loved it. So I trust them. They're very smart people. Simple Talk has some resources on doing a lot of this as well. And there are two great white papers that I have read and cannot recommend highly enough. There's a continuous integration white paper about how to do continuous integration with SQL Server. And it goes through all the steps you need to do, both from a, here is this process in general, and here is this process specifically with the Redgate family of tools. There's a fantastic approach to it. It sort of takes the idea of, you have no idea what we're describing in this paper. Let's walk you through it from the beginning to the end. And likewise, there's an automated deployment white paper to help you through using all these tools, describing specific scenarios. Because while I have described some ideas around what this might look like for you, this really is going to depend on your environment. And you want to start at the beginning with this very simple idea of, do I have backups? If no, then implement automated backups. And start moving slowly towards actually having a very ideal version of the world. It's very easy to look at that software development lifecycle graph and go, I go from development to testing to QA to production, and I keep just looping around, but that doesn't help you address anything. And instead, we want to go from backups all the way up to eventually get to continuous deployment, continuous integration. Everyone is happy because the code is always being tested. We know it's always safe. We know everything is good and wonderful, and we just focus on the things that are really, really fun about work. Because ultimately, work shouldn't be a chore. And I know it's work. They don't call it fun. But you should really enjoy your job. You're here, so hopefully you do. And if you have questions, if you want my thoughts, I will be here for a while, probably all day. If you want, unless someone's SAN explodes and they call me and Grant makes me go help them. And if you want demos, snag the fine people around and Noah Redgate. They're all wandering around wearing red shirts. If you're wearing a yellow shirt, feel free to give them a nudge in front of a laser. And you can find me online in a very, very large number of places, often sharing cat pictures with the world. Questions? It's a very quiet. Yes. App.net is a Twitter clone. That is basically people talking about app.net. Yeah, it's awesome. Brent's there too. Now you're all gonna go sign up.
So the cool thing about app.net is it costs like, what is it, 25 bucks a year?
I think they actually made it super free now or something.
It's not bad, so that at least that keeps all the people off who want to talk about cat pictures.
Yeah, apart from me and Brent. It keeps the spam away because you have to pay money to spam people, and spammers are like, why could I do that when I can do it for free with your email address? Question is not related to where I talk about cat pictures. Yes?
Have any slides on specifics for, say, continuous integration?
I do not have any specific slides for continuous integration. Do you have any specific questions about what the process would be, what it looks like? Or
Yeah, I mean, how does it fit in with
there's some continuous integration pieces. You're like, no, I'm not going to talk about these tools at all. I just work there. I don't know it. There's some continuous integration pieces. We could chat a little bit later and go snag somebody and actually get to a demo if you'd like. So you're in marketing. You want to tell us more? Excellent. Thanks. Yeah, yes, sir.
So how do you get a testing process to automatically start just because somebody checked something in?
That's actually part of the continuous integration. You hook it into the version control, and there's an agent in the background that'll run and look at when the last commit was. And usually you say, OK, after there has not been a commit in X seconds, then go through and run the test suite. Because you don't obviously want to be constantly checking code, because some people are like me, and they'll commit multiple times a minute as they make little changes. So you'll run it, and someone hasn't made a change in so many seconds, then you actually go ahead and it'll run and say, OK, there hasn't been a change in 300 seconds. I will now run the test suite.
So there's some process.
Yeah. It's not like there's hooks you can, no. There's hooks you put in either on an agent level or depending on your version control system. You can actually hook it into your version control system. You were next, and then you.
What are some of your favorite tools besides not from the database, but from the development?
So what are some of my favorite tools from the? So one of my favorite tools on the dev side for continuous integration. A lot of that depends on what environment you're in. In the Java universe, Jenkins is fantastic. It was originally called, it's the Travis CI now. Oracle bought Jenkins and was very, very upsetting in their treatment of it. But Travis CI is a fantastic continuous integration tool. TFS, like all other things TFS does a reasonable job. And then TeamCity is very, very nice as well, which will also work with the TFS source control. Yes, sir. Yeah. So where does Redgate fall down? Or where's TFS? TFS falls down a lot. I find it very complicated to administer TFS. Admittedly, I haven't worked with, the last version I worked with was 2008, which probably came out in like 2010 or something. I am not sure where the overlap between Redgate and TFS is and the variation is. I know one of the big difficulties is the Visual Studio database development testing tools are somewhat cumbersome to set up. And they're a little weird, and it all lives in Visual Studio as opposed to a lot of the unit testing in the Redgate tools actually lives in the database and is stored procedures and is written as stored procedures. So sort of a disconnect with the way DBAs and database developers normally think about the database versus TFS and the database testing tools, which is a sort of bizarre thing inside Visual Studio. Well, that would be a good question for a Redgate employee. I am not sure. I cannot speak enough to TFS practically. Most of my experience with it has been working with clients, and they've said, We tried TFS, and then we went to something else. From my own experiences working with it, it can be very frustrating to set up and configure and make it work well. So. Right, it's within TFS's CI.
Right, so whatever pane you have in TFS, you're still going to have it.
Well, parts of it. So Grant's comment is the Regate tools augment TFS for the recording and the people at home. Other questions? Awkward silence. Should I go back to the cat pictures? Yes, sir. Do I know when the SSAS tools for Regate are coming out? Yes, analysis services. I do not know. Grant, do you know? Are they in beta? So the analysis services comparison is in RC and coming out in a few weeks. Thank you. All product questions directed to this man. Other questions? You guys good? Did I answer your questions well enough? Do you have other ideas, crazy things you want to talk about? How would I set fire to? So the question was, when you're doing the unit testing, would I just restore a database from scratch, or would I actually do a full deploy and script the data into it? A lot of it's going to depend on what scenario you're trying to test. So if you're an ISV and you want to say, okay, what happens when I run a setup on a brand new product, you could even have a set of tests that deploy a brand new empty database and push metadata into it. Or what I usually do is, I usually recommend is take a known copy of the database and say, okay, the first of the month, this is our known copy that we're going to work with. And then we apply migrations from the first of the month through today, and then test the database. Grant points at his head, and then the database is magically blinded by this shiny. Yes, sir.
Can you speak to SQL source control, or is there another appropriate?
Is there an appropriate session about SQL source control?
Pardon?
Is there an appropriate session about SQL? I do not have a agenda in front of me.
Sandbox development processes.
Okay.
I talk a lot about source control
So,
and automated deployments and TFS and yeah.
everything. Grant. So what would you like to know about SQL source control? I can answer quick questions.
Branching and merging. When you merge back like static data changes,
Right.
If you do it through like SDN,
This will depend entirely on your diff merge process and how awful your version control is.
things get kind of boring. So
Yes.
then when you do it through SQL source control, then you have to check it in without the merge info.
Right. And, yeah, a lot of these metadata changes, they can be very difficult to script well, and a lot of it does depend on the specific version control mechanism that you're using to push them into place and how you've addressed metadata in sort of your project. So some of that is just going to depend entirely on your process. You then.
So how well does the Regate tools work with SVN, and what other source control? What if not SVN?
Sure.
What recommended?
So how well do the Regate tools work with SVN, and what are some other recommended version control systems? I know it works with SVN, Git, TFS, I think Perforce. I'm not sure. Oh, excellent. So pretty much everything apart from PVCS dimensions. And then, yes, sir. Yeah, there's a huge. Yeah. Sure. So sort of how does T-SQL-T play in? And T-SQL-T, you basically set up unit tests where you give it a descriptive name like verify that only a single user's first name is changed during update. However you want to descriptively tell it, and you actually say, okay, now run this stored procedure. Here's what the output of the procedure or function should be, and then you can tell it to verify metadata, verify the data in the database itself, and say what's changed, what hasn't changed. So you just script all these steps that you set up to say what makes this correct at the end of the test. So the idea is that you can walk through and do individual things and test your function and say, function add two numbers, 1, 1, the output is 2. And so you can set up failure and success conditions. You can modify and have pre-test activity that actually goes through and verifies that in failure conditions, it will fail appropriately, as well as in success conditions, it will succeed appropriately. So it's somewhat time-consuming to do at first. A lot of developers, when they first find unit testing, are sort of like, I'm not going to do this. This is extra work. But you then get that validation that you don't have to run through anything and test it over and over. So it can be as simple or as complex as you need it to be. So, right. Yeah. The idea is that the next time you need to verify something, the next time you need to change, you don't need to run through all the parameters. It's going to be passed into a stored procedure. You just say, OK, test. And you click the button, and it tests your code, and it's either green or red. And you're either happy or sad.
So if I change the stored procedure, how do I know which of my unit tests I need to change?
How would you know which unit tests you need to change? The ones that break? That would be a process question. Software cannot solve many process problems. Or it won't, because your tests are so awesomely thorough and your code's perfect. Yes, sir.
Which is the session this afternoon that you talk about kind of like, okay, here's what the UI looks like, and here's how it's integrated into the process.
The session this afternoon would be thwarting database defects. It is in the yellow room at 2:40 p.m. or 14:40 if you're on a 24-hour clock. And it's actually the guys who did a lot of the original work on T-SQL-T and continue to be the main contributors are doing that session.
Do you know if in T-SQL-T that doesn't like code coverage?
No, I think that'd be a code coverage tool. Do that. T-SQL-T is it's literally just a stored procedure testing framework that you can install in the database itself. Yes. Right. Yeah. And so the question was, does T-SQL-T do code coverage? And not to my knowledge, I don't know of anything that does code coverage for the database. The idea of code coverage is just that you run a tool that looks at all of your public interfaces and your application code and say, how much of this is actually being tested? How many of my code paths are tested? So that way you know how much work you need to do to make sure that things are safe and sane. I don't know of anything that does that for the database yet.
I'm not finding anything.
Yeah, it's a hard problem to solve, especially because SQL Server just parses text as a giant blob and eventually figures out what this blob of ASCII is supposed to do. If there are not other questions, if you have individual questions, you can come on up. And thank you, guys. Yeah. Autographs, eh? Where am I? Do you have a pen?
I got one right here.
Okay.
I did.